Hello, today we're going to be graphing quadratics in vertex form. So we're going to be starting off by looking at a graph that we have seen already. So on the left-hand side, that's your absolute value graph. We have talked about that earlier in this year. Looking at that graph here, that V shape, the bottom of the V shape is your vertex. That is your turning point. Your axis of symmetry would be a vertical line that goes through your vertex. So it's going to be x equals 0. Your domain is negative infinity to positive infinity because you have arrows going left and right on both sides for forever. Your range from low to high, our graph gets down to 0 and it goes up to positive infinity. Increasing and decreasing, we're going to start on the left side of our graph and we're going to trace it. So our graph here is decreasing and then all of a sudden it switches over to increasing. So increasing is the right half of the graph and decreasing is the left half of the graph. And that changes over when your x value is 0. So increasing starts at 0 and goes to the right for forever. And decreasing starts on the left half of the graph at negative infinity and stops when x is 0. So for those ones, as a reminder, you're always going to use parentheses with increasing and decreasing. So on to something new. This graph on the right-hand side is f of x equals x squared. It's a quadratic function versus an absolute value function. Your shape here is a U. But looking at this, your vertex is going to be 0, 0 because that is also your turning point. Your axis of symmetry is going to go through your vertex, and it's still going to be a vertical line at x equals 0. My graph still has arrows on both sides, left and right, for my domain. Low to high, my graph still goes down to 0 and up forever to infinity. My graph starts off decreasing here and then moves to increasing. So my increasing interval is going to start when x is 0 and go to the right for forever. And my decreasing interval is going to start at negative infinity and go all the way up until 0. So you'll notice almost everything is identical. So it has the same idea of going down and going up and having that vertex, that turning point. But what's different is the shape of the graph. The absolute value here is the V shape. The quadratic is the U shape. And that U is called a parabola. So let's look specifically at a couple of points that make that quadratic x squared graph. So we're going to go ahead and use our x values here to figure out our y value. We're going to plug in the x value and square it. So be careful with this one because we want to make sure we are doing negative 3 squared, which would be a positive 9. Negative 2 squared would be a positive 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So this would be the way our graph looks. If we graph all of these points and then connect them, that creates that nice U shape. That creates the parabola. So all of our graphs for quadratic functions are going to be this parabola. This one happens to start at 0, 0 with an axis of symmetry that goes through your vertex here. But we're going to start moving things all around. So we want to figure out what our graph of our quadratic functions look like and how do we move them all around. So that's this next part. I would like you to go ahead and go to cosmos.com and then you can click on the calculator button. It's not the student section, it's the calculator one. So it should look like this. We're going to go ahead and type in our first equation, f of x equals x plus 3 squared minus 2. Oh, I forgot my parentheses. You want to make sure that the x plus 3 is in parentheses, squared minus 2. And we want to look at the vertex of this graph. So your vertex here is over 3 to the left and then down 2. So we're going to go ahead and graph that left 3, and down 2. -3, -2. We also want to come up with a couple more values. So if you click the cog up there, you can click on the table, and you should get to this table of values to help you graph a couple more points. So -2, -1 is a point. -2, -1, and it was -1, +2. And I want a couple more negative points, so I'm going to type in like -3, -4 is at -1, and -5 is at 2. I want a couple of points around my vertex to help give me that shape. So looking at this, my graph, if you were to compare it to what the normal parabola looks like, this is what the normal parabola looked like. My vertex was at 0, 0. This moved left 3 and down 2. So I would like you to then pause the video and try examples 2 and 3 and all of example 4. And then once you're done with that, unpause the video and see how you did. Okay, let's check in here. So for number 2, our vertex should be at +4, -5. We moved right 4 and down 5, and then you can see the couple points on the other side. Then for the next one, we moved left 1 and up 3, making your vertex -1, +3. Notice for all of those, whatever's inside the parentheses, you do the opposite of that for your x value. And then whatever's outside the parentheses, that's your up and down for each of these. And that's going to make for these ones, number 4a, 2, 8 would be your vertex. 4b, the -11 is at the end, so that's going to be down 11, and there's nothing with the x, so it's 0. And then the next one here, you have the +8 inside, which moves it left 8, and then there is nothing added on at the end, so we use a 0. So you should notice that these quadratics are following the exact same rule that our absolute value graphs did. Remember how like this was your left and your right, your h, but it was the opposite. Your k was your up and your down. And then your a is going to end up being your stretch, but quadratics does it a little bit different. But your left and your right and your up and down are going to match your absolute value graphs. So we're going to be doing all of these different transformations on these quadratics. So A, we're not going to talk about today too much, other than it is going to stretch and compress and reflect. We'll talk more about how do you actually graph that tomorrow. H is going to be your left and your right. And it's going to be going right when you have x minus a number in the parentheses. It's going to be going left if you have x plus a number in the parentheses. The k at the end is going to move your graph up or down. It's going to go up if you have plus a number at the end, and it's going to go down if you have minus a number at the end. So in this form, your vertex is going to be h, k. Your axis of symmetry is always going to be a vertical line that goes through the vertex. So your axis of symmetry is always going to be x equals, that's what makes it a vertical line, and then the h value of your vertex. So whenever you know h, you actually know a lot of different things about your quadratic function. All quadratic functions have a domain of -infinity to +infinity because it's going to go left and right for forever. But your range, it depends on your graph. You are either going to start at your k value of your vertex and go up for forever. That's if your graph looks like this, or if your graph is flipped upside down, you're going to start at -infinity and then you're going to end at k. The other thing that I'd like you to write down here, and it will make more sense coming up, I want you to write down 1, 3, and 5 pattern. So this is the pattern to graph your functions, 1, 3, and 5. And you'll see what I mean in just a moment when we do the next example. Okay, so for number 1 here, this -1 is going to move our graph right 1. The -3 is going to move it down 3. So if you're a visual person, go right 1 and down 3. And so your vertex should be at 1, -3. Your axis of symmetry is going to go through that point. It's going to be x equals 1. Your domain is -infinity to +infinity. And your range, now we probably should graph the rest of this. So here's where we're going to bring back that 1, 3, and 5 pattern. What we're going to do is we're going to go over 1, and then we're going to go up that first 1. And then we're going to go over 1 and then up 3. And then we're going to go over 1 and up 5. It's always going to be over 1. So from your vertex, go over 1 and up 1. But you're going to do it on the right-hand side and on the left-hand side because it's symmetrical. From this new point, you're going to go over 1 and up 3 to get to the next one on each side. So over 1 and up 3. And then I'm going to kind of erase my route there because I only want the points really. And then from that point, I'm going to go over 1 and up 5 to get to my next one. That's where that 1, 3, and 5 pattern goes. That's how we get to our next point. We're going to go ahead and connect all of those, and then we can see now that our range is going to start down at -3 and go up for forever. Half of our graph here is going to be decreasing, then half of our graph is going to be increasing. So our increasing starts when x is 1 and goes to the right for forever. Our decreasing starts at -infinity and stops when x is 1. Remember, you can view this as -infinity, +infinity, and whatever your x value of your vertex is in the middle. Let's see another one. So for this one here, this +4 is going to move my graph left by 4. I don't have anything at the end here, so left 4, that's it. That's where my vertex is going to be. So -4, 0. My axis of symmetry is going to go through that. It's x equals -4. And I'm going to use that 1, 3, and 5 pattern to get to my next points. So I'm going to go over 1 and up 1. And then over 1 and up 3. And then over 1 and up 5. And then I connect those to get my parabola. My domain would be -infinity to +infinity. For this one, my range would be from 0 up to +infinity because my vertex had a y value of 0. My increasing half is the right half of the graph, whereas my decreasing half is the left half of the graph. And where I stop decreasing and start increasing is at that -4. So increasing starts at -4 to the right, decreasing starts to the left, and then stops at -4. And lastly, now we can use this to write a quadratic function. So if you're a visual person, you can graph this 1, 2, 3, 4, 5, 6. Our graph is supposed to look something like this. So our equation should look like this. Our a value, we're just going to use 1 for today because we haven't changed that at all. We are not moving left and right at all. So your h value is 0, and your k value should move your graph down 6. So this equation should be y equals x squared minus 6. So thank you very much for listening. Let me know if you have any questions.